Okay, is that good? Yeah. All right, well, I want to thank all of you for coming out and seeing us. It's kind of extraordinary, actually, what's going on here this week. It's a bit like a festival of astronomy. It certainly made us feel a lot more welcome in town as we come and have our meeting. But we don't get too many opportunities like this to talk to people outside research, astrophysics. And it's actually really good for us. It reminds us how exciting the stuff we do is and gets us out of our offices. Okay, so I'm an astrophysicist. What that means is I try and understand how things out there in the universe work by making models of them. So I like to think of astronomers as people who make careful measurements of things in the universe. Astrophysicists are trying to make models to understand things. And that's partly because we want to know how they work. We're like you, we want to know. But there's also an element to it, I find, which is that there's something special about just being able to look up at the night sky and then go to work and try and make representations of it. I got this idea of us representing the universe from Richard Holloway, who's an amazing man. And he likes to remind people that we as humans, we're the way in which the universe is asking questions about itself. So I like to remember that with people when I come and give talks. So the main thing I wanted to do tonight was tell you a short story of a project we did recently, a couple of years ago, and it's kind of ongoing, where we're trying to weigh the Milky Way galaxy. So we do that by making a model of it. We represent the Milky Way galaxy. And not just the galaxy of stars that we live in. You've probably seen it in the night sky, but it's dark here in France. So you've seen the Milky Way, it's a stripe of stars across the sky. But there's more to the Milky Way than that. There's the stars, there's also the gas and the dust between the stars that we know about. But we also now think that there's dark matter in the Milky Way. And all around the Milky Way, sort of like a cloud of it. We call it a halo, but you shouldn't think of angels' halos. Think of a cloud. And so, we'd like to understand how that works, and we'd like to make maps of where the dark matter is. We'd like to understand where the dark matter in our galaxy is. So it's good for us to think about how to do that. And so I was at coffee time in my institute and listening to a very interesting talk by somebody in our institute who was trying to do not that project. He wasn't trying to figure out where the dark matter was. He was trying to answer the question, how unusual is our galaxy? So there are many galaxies we see in the sky with telescopes, and he was interested in how unusual is the Milky Way. Because he'd noticed that we have these two satellite galaxies. You can't see them from the north, you can only see them in the south. They're called the Magellanic Clouds, and they look like little fuzzy blobs on the sky. So we have these two Magellanic Clouds, and Michael thought, well, this is a bit odd. I wonder how many other galaxies have two Magellanic Clouds, or satellites orbiting them. And so he went and looked in the Sloan survey, and he found that maybe 1 in 20, something like that, galaxies like our Milky Way have two Magellanic Clouds. So, somewhat unusual. And then he thought, well, this is a way we can maybe test our model of how the universe works. So he went to his big catalogue of simulated galaxies, where he ran a giant computer simulation of the whole universe, and then seen where all the galaxies form, and then made lists of them, and found the ones that had about the same mass as the Milky Way. And then he asked, well, how many of them have two satellites? And he found about the same answer. Sort of something like 1 in 20 have two satellites. So he was showing us this at tea, and it was pretty interesting, right? I didn't know that we were a 1 in 20 special kind of galaxy. But he was giving this talk, and then the best part about talks in research are the questions afterwards. So you always get all the best out of the questions. And somebody said, are any of the galaxies that you found in the simulation really like ours? Like, could we use them as actual models for the actual Milky Way? Because these simulations, they're not tuned to reproduce the real things we see, they just kind of get things right on average. But somebody wanted to know, well, did you find one that looks exactly like the Milky Way? He said, well, maybe there are a few. And then we realized if we got those few from our simulation, the ones that really look like the Milky Way, that have two satellites like the Magellanic Clouds, that are moving at the right speeds and at the right distances, then we could take those and say, well, these are good models for the Milky Way. And then we could ask from each one, how heavy is this one? How heavy is this one? How heavy is this one? And get some picture of how massive, how heavy our Milky Way is. So we did that. That was a research paper. And then part of that investigation, after we've weighed the Milky Way, there are other interesting things you can do. Once we've got these model halos of dark matter from that simulation, we can ask, well, their model magellanic clouds, when did they arrive? Did they arrive 1 billion years ago? Or 10 billion years ago? And we could go to each one and ask, how old are the Magellanic Clouds? And we found that most of the time they came in very recently in the model Milky Ways. And so now we think that the Magellanic Clouds also arrived quite recently, maybe in the last 1 billion years. So this is pretty interesting, I think. It's a way of modelling our galaxy by going and looking in a giant simulation of the whole universe for other galaxies like ours that we can learn from. So these halos, they said they were like clouds. They're not quite spherical, they're sort of blob-shaped, but you should think of a dark matter halo as a giant cloud of dark matter, and somewhere in the middle of it there's a disky galaxy that will be the Milky Way. And they look like fried eggs, by the way. You know, they have a bulge in the middle and then a disk of stars or anything else. And so these blobs of dark matter, these halos, it's interesting to think about that when you go out and look at the night sky. So my favourite constellation is Cygnus. How many of you know where Cygnus is or would recognise it? Not very many, right? I'll tell you how to look at it. The next time it's dark, you've got to look at Cygnus for me. It's my favourite. So if you find the Big Dipper, you know it looks like a spoon shape. If you go to the end of the spoon and you look up the far side of the spoon, it points to a particular star. Do you know which one? The North Star, exactly. So if you go from the Big Dipper out to the North Star, and then keep going about the same distance on the other side, and a bit to the left, what you see is a constellation that looks like a swan. It's called Cygnus, it's got 2 wings, like this, and it's got a tail. The tail's very bright, and then there's a sort of faint neck and a somewhat bright head. So that's Cygnus, and it's in the Milky Way. If you're in a dark place, you can see that this constellation is part of this stripe of stars across the sky. So we know those stars are in the Milky Way, and in fact, it's the direction, you look towards Cygnus, that's the direction we're moving in. So we have a disk of stars, we're here, somewhere in the suburbs, very boring, and we're going round the galaxy once every 200 million years or something. And we're moving at 200 kilometers per second, which is also fun to think about. And as we move around the galaxy, we're moving in this disk, so we're moving towards the Milky Way in the sky, and the particular direction we're moving in is where Cygnus is. So, now we know that the galaxy is a disk of stars that we see as a stripe on the sky, and it's living in this giant halo of dark matter. And the dark matter particles seem to be going every which way when we look in the simulations. They're not rotating in the disk, they're like a cloud, they're doing this, their orbits are all over the place. We don't say all over the place, we say the orbits, we don't say. So it's a bit like we're flying through a cloud of gas. So you know what it feels like to fly through a cloud of gas. When you're cycling along, you feel the wind in your hair. So we're flying through a cloud of dark matter. And if we were able to feel dark matter in our hair, we'd feel it from the direction of Cygnus. So I like to go out at night and look at Cygnus and imagine the dark matter wind blowing. Okay, thanks very much.